Here we're going to be taking a look at angle, side, angle, triangle congruencies. So the angle, side, angle theorem is that if two angles and the included side of one triangle are congruent to the two angles and included side of another triangle, then the two triangles are congruent. So if I have two triangles here, A, B, C, and D, E, F. If angle A is 45 degrees and angle D is 45 degrees, and then A to B is 2.3 centimeters long, and D to F is 2.3 centimeters long, then we get angle B being 61 degrees. That would mean that angle F is 61 degrees. And in the case of these two triangles, then they are congruent to each other. The third angle has only one choice, and these angles set up, if you were to try to construct this, there would only be one triangle you could construct following this angle, side, and angle. Now the angle, side, angle must be touching each other. This is useful for us in a few different ways when it comes to writing proofs. Let's suppose I had a pair of triangles like this, M, N, P, and Q. If we had the angle MQP is congruent to angle NPQ, then we know we have two congruent angles. If they also gave us that angle MPQ is congruent to angle NQP, I know two angles, but I need an angle, side, angle. It is this shared side. PQ is the same as QP. They're a shared side in those two triangles. This is going to mean that we have an angle, side, angle triangle congruency. Another common way that they might try to give us is with a setup like this. So let's go ahead and name these points A, B, C, D, and E. And they might go ahead and give us some criteria, like saying that angle A is congruent to angle C, and that E is the midpoint of AC. So knowing that E is the midpoint of AC means that AE is congruent to EC. That is our definition for midpoint. But we'll also remember vertical angles as a definition, which means that these two angles here, vertical of each other, are congruent to each other, creating that angle, side, angle congruency. What if they gave us yet another setup? What if they gave us something along the lines of this? And we'll go ahead and say J, K, L, M. And in this case, they might say that JLM is congruent. So I like to break it off. So we have JLM. That angle is congruent to KML. So this angle is congruent with this angle. Then they might say that JML is congruent with KLM. So JML is congruent with KLM. So we have angles being congruent to each other. And once again, we have that shared side. So when it's split apart, it might not be as obvious as those two are congruent to each other. But shared sides is a very common trick that they'll try to play on you in the state testings, in the Common Core testings. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent to each other. Remember, math rocks with a capital M.